In this lab, we observed a magnet falling through an aluminum foil tube and modeled the interaction between the magnet and aluminum foil in GlowScript. First, I set up the measurements according to the experiment I conducted in real life. So we have these, and we have this. And then I set up this method here from lab 3 to calculate the magnetic field at a certain distance from the bar magnet. And this method here is used to calculate the rate and change in the magnetic flux through a ring caused by the magnet. And then down here, you can see Faraday's law being put into effect to calculate the current induced in each ring by the magnet, and the Biot-Savart law to find the force that the magnet exerts on the ring. And Newton's third law allows us to infer that the force that the magnet exerts on the ring will be equal and opposite to the force that the ring exerts on the magnet. I then included gravity to find the net force, and I used the principles of Newton's second law here to find the velocity of the magnet and the position of the magnet. Now, if I run this, you will see that the magnet is falling through the tube, and as the magnitude of its velocity increases, its acceleration begins to decrease because this magnetic force that we calculated earlier increases in the direction of gravity as a function of the magnet's speed, as you can see in this method here with speed in the numerator. And now we have to consider, what could have happened if we changed a few things about this experiment and did it again. So for example, what if the resistivity of the tube was reduced to a value closer to 0? And what we can actually do is we can actually test this exact situation. We can say, let's say this is 0.01 times 10 to the negative 8 is the resistivity. And so this is a value really close to 0. And as you'll see, what ends up happening is that this simulation, in this simulation, the tube essentially it's like an infinitely long tube. So you can see that the force of the magnitude, the force of that the rings exert on the magnet is so great that it exceeds the force of gravity and shoots the magnet upwards. And so you can see that this is because of Faraday's law earlier. You can see that the current is an inverse function of the resistance. So as the resistance decreases, the current increases. So as the resistance decreases closer to 0, the current is approaching infinity. And as a result, the magnitude of the magnetic force is also approaching infinity. And another question we can explore is what if there were holes or slots cut into the tube? And the answer is that really not a whole lot would change. So essentially what would happen is that these rings would look a little different because they wouldn't be able to go in a perfect ring around the tube because there would be holes in the way. So it would have to go slightly around it. The rings would essentially just look a little bit different from what they are here. And as a result, the current would usually have to travel a longer distance and it would encounter more resistance, and therefore the current would be lower and the force pushing upwards would decrease as a result. But overall, it would probably still be fairly close to the situation without holes, and the situation without holes would probably be a good estimate of it regardless. Anyways, that's all I have. Thanks for watching my lab, and good luck on finals.